In this video, I will cover a variety of IPv6 topics in a comprehensive, easy-to-understand manner. Feel free to check the timestamps in the description below to see the various topics covered in this video. With that being said, let's begin the video. Internet Protocol version 6, known as IPv6, is the most recent version of the Internet Protocol. This new version was developed because of the rapid growth of technology, increased number of devices connected to the Internet, and the inevitable exhaustion of IPv4 addresses. IT professionals have anticipated the exhaustion for a while now and had to come up with a newer Internet protocol to support these changes in this ever-evolving world. Before we talk about IPv6, you need to know that IPv4 uses 32-bit addresses and is composed of 4 octets, which is 8 bits per octet. This means IPv4 can support around 4.2 billion unique addresses. To be exact, the number is 4,294,967,296. This number may seem like a lot, but in simple terms, it's not. Unlike IPv4 addresses, IPv6 uses 128-bit addresses. As you can see, this address is way longer and uses a hexadecimal number system. This provides a very large number of unique addresses. I don't even think that number is possible to pronounce, but I don't know. What I do know is that this number will support the growth of plenty devices for many upcoming years. V6 addresses are represented as 8 groups of 4 hexadecimal characters, known as a hextet. Each hextet is separated by colons. For host systems, the first 64 bits are known as the prefix. For common V6 address types and host systems, the last 4 hextets are reserved as an interface ID. Interface IDs are used to identify specific interfaces on a node. If you don't know common IPv6 address types, then continue watching the video as I will cover these common address types. Since these addresses are pretty long, we can simplify them by using standardized rules known as address compression. First, we can remove any leading zeros. These are zeros that are at the start of each hex text. We can't remove any trailing zeros, which are zeros that are not at the beginning of the hextet. Let's apply this rule to this address. So in this first hextet, all 3 zeros are removed, leaving the letter C. We can also remove the leading zeros in the 4th and 6th hextet. In the second hextet, there are 4 zeros. Whenever you see 4 zeros, you want to remove 3 and leave 1. There are zeros at the end of the 3rd, 5th, and 8th hextet, but since they are trailing zeros, they will be written the same. If the rule doesn't apply to a hextet, then simply bring the number down. As you can see, all the leading zeros in each hextet have been removed. This already shortens this address a decent amount. Let's move on to the second compression rule with a new IPv6 address. Rule number 2 is to remove consecutive sections of zeros with a double colon. This can be used only once per address and can be used anywhere in the address. In this address, you see 3 consecutive groups of zeros. This meets the criteria of rule number 2, allowing the groups of zeros to be replaced with the double colon. Let's try another example. As you can see, there are 3 consecutive groups of zeros towards the middle of the address. Once again, we can replace all these zeros with a double colon. Now that you know both rules, pause the video and try to apply both of them to all 3 addresses. I will reveal the correct answers in a couple seconds, so make sure to pause the video. If you got any of these wrong, feel free to re-watch the rule you struggled with and come back to this part. I guarantee you will understand why the correct answers are abbreviated the way they are. Let's discuss the 3 address types in IPv6. The three address types are Unicast, Anycast, and Multicast. First, we will discuss Unicast. Unicast refers to a one-to-one communication model where data is sent from a single sender to a single destination. Unicast addresses specify a single interface on the network. Four common types of IPv6 unicast addresses are global address, unique local address, link local address, and an unspecified address. To start, global unicast addresses are equivalent to IPv4 public addresses. They allow a single interface or node to be exclusively identified on the Internet. This allows data to be sent outside of the local area network. You can identify this type of address by looking at the prefix. All global unicast addresses start with this same prefix. In binary, they will start with 001. Next is a unique local address. These addresses are essentially the same thing as an IPv4 private address. This means that it can only be used to send data between devices on a local or private network segment. These addresses are not able to route information out to the public Internet. Unique local addresses can be identified by this prefix. The next type of unicast address is a link local address. This address represents a single physical link and only allows communication within the local subnet or local broadcast domain. These addresses are automatically configured by the host for each interface. The prefix for this address would be FE80:10. Now let's talk about an unspecified address. This one should be fairly simple to understand. This address is used when an IPv6 host has not been configured with an address and has not learned its host source address. In instances like this, the host needs to request a valid one through the DHCP version 6 or Slack network protocols. The prefix for an unspecified address is :128. The next address type in IPv6 is an Anycast address. Anycast refers to a one-to-nearest communication model where one address is assigned for multiple interfaces on different endpoints. This means multiple destinations can be logically identified by one address, allowing a packet with an Anycast address to always be sent to the closest destination. This address is mainly associated with servers or routers, as it allows servers to be distributed around the world. In this model, the client can send data to all three servers. But when it comes to networking, we always want the most efficient path. Server 1 is the closest to the client, meaning all requests will be forwarded there. Since server 2 and 3 are further, they will be on standby in case the primary server goes offline. This provides redundancy, load balancing, and efficient network paths. The last address type is a multicast address. Multicast refers to a one-to-many communication model where data is sent from one sender to multiple possible receivers simultaneously. Multicast is similar to IPv4's broadcast, but the main difference between them is that multicast will only transmit data to designated receivers, while broadcast transmits data to all receivers and does not require a response. Many protocols use multicast because of its benefits to transmitting data to specified recipients. Here is a full list of IPv6 protocols that use multicast addresses, along with their corresponding prefix. Unfortunately, I won't cover what each protocol is in this video, but subscribe and be on the lookout for a video covering protocols. Understanding IPv6 is crucial as the Internet continues to evolve. The adoption of IPv6 is essential because of the inevitable exhaustion of IPv4 addresses. If you found this video helpful, let me know in the comments section down below. Don't forget to drop a like and subscribe for more simplified, easy-to-understand videos.